Hello, this is Dr. Monica B. Mohiti and I welcome you all. So this happens to be our first session on linear differential equation, which happens to be the first unit for SY BTech third semester engineering mathematics for almost all the trades, right? So whether it be civil, mechanical, ENTC, electrical, almost for all the trades, this happens to be the first unit. So in this unit, we are going to study all these topics. So in our last semester, that is semester 2, we have studied linear differential equations of first order and first degree. First order and first degree. Right? That is the equation of the form dy by dx equal to f of xy. So in this semester, that is semester 3, we are going to study linear differential equation of first degree and order more than 1. First degree and order more than 1. That is 1 plus more than 1. So let us get started with our unit. So this unit is going to be a very easy unit and all the methods depends on the value of RHS, and the total unit is going to be a very easy unit. Before going into the unit, I want to have a recapitulation, a recap, so that we can understand the unit in a better way. Recapitulation or a recap. So firstly, what is meant by a differential equation? Differential equation, short form for differential equation is DE. What is meant by a differential equation? An equation which involves or which contains differential coefficient. Right? It can be dy by dx or dx by dy. So any equation which involves differential coefficient is nothing but a differential equation. Right? An equation which involves differential coefficient is known as differential equation. Now we know what is a differential equation. Now in differential equation we have two types: ordinary differential equation and partial differential equation. Differential we have two types, ODE and PDE. In ODE, the derivatives are with respect to one independent variable. If the derivatives involved are with respect to one independent variable, then it is known as ordinary differential equation. And if the derivatives are with respect to more than one independent variable or with respect to partial derivatives, then it is known as partial differential equation. More than one independent variable, derivatives involved are with respect to more than one independent variable, then it is known as a partial differential equation. Now we know what is a differential equation and the types. So what is an order? The order of the differential equation is the highest order of the differential equation. Highest order of the derivative is nothing but order of the differential equation. Highest order derivative of the differential equation. And what is the degree? The degree is the degree of highest order derivative. What is degree? Degree is the degree of highest order derivative. Degree of highest order derivative present in a differential equation. Right? So all this already we have learned, and Also we know whatever is the order of the degree, order of the differential equation, order is equal to number of constants occurring in the differential equation. So whatever is the order, those many number of constants will be containing in the solution part, right? And also we know when I say equation, we have two types. So what are those? Those are nothing but homogeneous equations and non-homogeneous. So what is meant by homogeneous differential equation? If the value of RHS is 0, then that is nothing but homogeneous. When RHS value is 0, that is nothing but homogeneous. And when the RHS value is not 0, then it is known as non-homogeneous. So this was all for the recap. So now let us dig into our third semester, that is engineering mathematics, and unit number 1, linear differential equations. So firstly, let us know the meaning of linear differential equation. So now let us start our unit. So linear differential equation, introduction. Linear differential equation. Short form for linear differential equation is LDE. Linear differential equations. Linear differential equations are those in which the dependent variable and its derivatives are of first degree only. First degree only, and are not multiplied with each other. First degree only and are not multiplied together. So general form of linear differential equation of nth order. Let us see general form of linear differential equation of nth order. So general form of linear differential equation of nth order. So nth order differential equation of y with respect to x plus p1 dn minus 1 y by dx raised to n minus 1 plus p2 dn minus 2y by dx raised to n minus 2 plus dash 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 plus p and y equal to capital X, where p1, p2 and so on up to pn are functions of x, and capital X is also function of x. So this is known as general form of linear differential equation. Now, what is meant by linear differential equation with constant coefficient? So general form of linear differential equation with constant coefficient. Same form, dny by dx raised to n plus p1 dn minus 1y by dx raised to n minus 1, n minus 1th derivative of y, plus p2 n minus 2 derivative of y with respect to x, plus dash 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 plus p and y equal to capital X. So what is happening for definition of linear differential equation with constant coefficient? In this, p1, p2, so on pn, they are nothing but constant, and your capital X is function of x. So this is nothing but general form of linear differential equation with constant coefficient. So what is the general form? dny by dx raised to n plus p1 dn minus 1y by dx raised to n minus 1 plus p2 dn minus 2 by dx raised to n minus 2y plus dash 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 plus p and y equal to capital X, where p1, p2, so on pn are constant and x is nothing but function of x. So this is definition of linear differential equation with constant coefficients. right? Now let us see what is meant by operator D. So operator D. So as already we know, the operator D, it stands for D by dx, differential operator. So D stands for D by dx. So what you can tell about dy? So that is nothing but dy by dx. What you can tell about d square? D square is nothing but d square by dx square. So d square y is nothing but d square y by dx square. D cube is nothing but d cube by dx cube, and so on. So this is the meaning of operator D. D stands for differential operator, that is nothing but d by dx, right? So general form of linear differential equation can also be written as, so already we have seen nth order, it is written as dny by dx raised to n, so on. So same this form we can also write in the form of using the D operator. So already now that we know D stands for d by dx, differential operator. So this I can write as, this is nothing but some function of D. So I can write as function of D into y equal to capital X. So general form of linear differential equation with constant coefficient, alternative form is nothing but f dy equal to capital X, right? So from now onwards we will be remembering this, f dy equal to capital X. Very easy it is to remember. Now already we know we have two different types of equations. So what are those? Homogeneous, non-homogeneous. When I say homogeneous, for homogeneous RHS is 0. So how I can write? F dy 0, because RHS is 0. So linear differential equations for homogeneous equations is f dy equal to 0. Now solution for homogeneous. Solution for homogeneous is nothing but solution in the form of y. We write as y equal to complementary function. That is, when the RHS value is 0, it is known as homogeneous. And at that time, what is my complete solution? Complete solution or general solution is nothing but y equal to CF, complementary function. Now, homogeneous equation is one type. Another form is what? Non-homogeneous equations. Non-homogeneous means what? RHS value is not 0 but some function of x. For non-homogeneous, so what is my general solution? I have to find out CF first. So CF stands for complementary function. So I have to find complementary function, and further I have to find particular integral. So this is the solution for non-homogeneous equations. So particular integral, for different cases you have different method to follow. All that we will be seeing in our next sessions. So right now just let us understand. So how is the solution for homogeneous is given as y equal to CF, that is just complementary function. CF stands for complementary function. In exam we can just write CF. And for non-homogeneous equations, that is RHS is not 0 but some function of x. At the time, how we can write our complete solution? It is nothing but y equal to CF plus PI. So in our next sessions, we are going to see how to find CF. That is, today we have seen introduction, what is meant by linear differential equation, what is meant by linear differential equation with constant coefficients, and what is meant by homogeneous, non-homogeneous equations. So in next session, we are going to see rules to find CF, that is complementary function. So this is nothing but solution for homogeneous equations is y equal to only CF. So thank you dear viewers. Thank you one and all. With this next session we will continue. Thank you.